Hello, campers. Today's lesson is on scientific notation. Shorthand for large numbers, made up by scientists. Get it? It's an atom? Maybe? I don't know. That's what I thought an atom would look like. So, what you need to know in order to do this is, we're going to have 6 boards of notes. You're going to take notes before I start talking. So pause the video now, take down this board worth of notes, and then start the video again when you're ready to hear me blather on. Okay, so in order to do this, you need to be aware of the powers of 10, and we've gone over the powers of 10, and I'm going to review it for you in a second. You also need to know that scientific notation is only written with decimals that are greater or equal to 1 and less than 10. So, for my mathematically adept friends, the decimal has to be in between 1 and 10. It can be equal to 1, but it has to be less than 10. So basically single digits. This is an example of scientific notation. 4 is in between 0 and 10. It's greater than 0 and it's less than 10. Don't let the number of decimal places confuse you with the fact that this digit right here has to be greater or equal to 0 and less than 10. And then I multiply by a power of 10. Here I have 7 and 87 hundredths. Again, 2 decimal places, but 7 itself is greater than or equal to 0 and it's less than 10. I can have a negative power of 10, and that's still scientific notation. When I have a positive exponent, that means I have a pretty large number. A negative exponent means I'm going to have a pretty small number. And by small, I mean less than 0, or less than 1. It's going to be a decimal. Let's play Is It Scientific Notation? So you're going to go ahead, copy this slide down, hit pause, and then tell me, is it scientific notation or not? Okay, welcome back. 1 and 8/10 times 10 to the third. Is this scientific notation? Yes, it is. 3 and 75 hundredths times 10 to the negative 5th power. Is this scientific notation? Yes, it is. 1/4 times 10 to the 8th power. Is this scientific notation? No, because this number is not a digit. So while it is greater than or equal to 0, it also has to be an integer. This isn't going to count as scientific notation. 78 and 1/10 times 10 to the 2nd power. Is this scientific notation? No, because 78 is greater than 10, and my numbers need to be less than 10. How about 53 times 10 to the 5th power? Is that scientific notation? No, because 53 is a whole number greater than 10. These are examples of powers of 10. If you don't already have an understanding of how the powers of 10 work, go ahead, press pause, and copy these down in your notes. Okay. If you're asked to write these numbers in standard form, these are scientific notation numbers, go ahead, pause the video, get this copied into your notes, and then we're going to work on writing each one in standard form. Okay, welcome back. You guys are the best pausers ever. 1 and 9/10 times 10 to the 6th power. That tells me that I'm going to have the decimal originally here, and I'm going to be multiplying by 1 million, because 10 to the 6th power is 1 million. Another way to look at that is, and I don't love this method, but whatever gets you through the day, right? 10 to the 6th power means I'm going to scoot this 6 times. 1, 2, 3, 4, 5, 6, and I'm filling it in with zeros. $1,900,000. 4 7/500 times 10 to the 3rd power. 4, 7, 5. This is 1 decimal place. This is 1 decimal place. And because I had to move it 3 decimal places, I'm only going to add 1 0. So when my decimal was 4 7/500 and I multiply by 1,000, I'm looking at 4,750. If I have 8 7/10, and now I have negative 10 to the negative 4, what that means is when I have a negative exponent, this is a decimal number. So I'm going to have 1, 2, 3, 4 scoots, and I fill in those blanks with 0. My number is 87,000, no it's not, it is 87 hundred thousandths. Okay, now you're going to write each number in scientific notation. So now we're going to do the opposite. Take a second, pause, and copy that down. Welcome back. All right. Here's the decimal. Every number has a decimal at its end. In order to make this into scientific notation, I want to divide by a power of 10 that's going to make the whole number shift so that I only have 1 digit in front of the decimal. The cheat is 1, 2, 3, 4, 5, 6, 7. This number is going to be 8.6 times 10 to the 7th power. If I have a decimal number and I need to put it into scientific notation, because I'm moving in the opposite direction to indicate that I have a decimal number, I know that I'm going to have a negative exponent, and now I have 1 25/100 times 10 to the negative 2nd power. Computing with scientific notation. If you remember how to multiply exponents and divide exponents, we should be okay, because that's part of our computing with scientific notation. Go ahead, press pause, and get this slide copied down before you move on. Hello, and welcome back. Okay, when I'm multiplying, if I have 1 5/10 times 10 to the 3rd power times 6 4/10 times 10 to the 4th power, I'm first going to be multiplying my numbers together. 1.5 times 6.4 is going to get me 9 6/10. Then I'm going to go ahead and multiply my powers together. And because my bases are the same, I'm going to go and follow the multiplying powers law, which says I'm going to add my exponents. Only if my bases are the same. Both bases are 10. 3 plus 4 is 7. So my new scientific notation number is 9 6/10 times 10 to the 7th power. If I have 2 scientific notations multiplied together and one of them is a negative exponent, I'm still following the same procedure. I'm going to multiply my numbers together, my decimals. I'm going to add my exponents together. I have a negative 3 plus 5. I'm looking at 10 to the 2nd power. The problem is 22 318 thousandths is not already in scientific notation. So I have to adjust for scientific notation by making sure that my decimal is in the correct place. But when I did that, I increased the number of decimal spots that I had to multiply by. So I have to adjust my power of 10. And the last slide is on dividing. Go ahead and take a second and copy this down. Okay, when I'm dividing, I'm going to follow the same procedure. Divide my decimal numbers. 5 and 24 hundredths divided by 2 and 62 hundredths equals 2. It's a whole number. We can write it as 2 and 0 tenths, but the bottom line is it's greater than or equal to 0 and less than 10. I go ahead and divide my powers, and because they're the same bases, I can just subtract the exponents. So my result is 2 times 10 to the 4th power. Go ahead and try me. Okay. When I divide 8 and 75 hundredths times 10 to the negative 4th by 4.1, you're going to come in tomorrow with this done. So that I know you watched the video. If you can produce this answer, then you get the brownie point. If not, we'll get it in class anyway. We'll see you tomorrow.